Well, math analyzers, here's the last lesson of chapter 3. We are on to chapter 3, lesson 10 notes, and we are going to solve quadratic inequalities. And this is going to focus in on factoring just like the last one did. So we're going to stick to the factoring, okay? We solve quadratic inequalities graphically when the quadratic is, ready? Y equals y is less than or equal to ax squared plus bx plus c. So there's two variables, right? X and y. But if it's 0 is greater than or equal to, or less than or equal to, or whatever the equal to, right? The less than, the greater than. It's ax squared plus bx plus c. When there's one variable, that's when we solve algebraically. Okay, that's when we're solving this algebraically. So the key here is, just like with equals, you have to have one side with your 0 and all the rest of your polynomial on the other side. You have to have them in standard form. So ax squared plus bx plus c. Okay, and then as an answer, as a rule, once you're finished solving, we check our answers to see where they fall in the number line. So this is where the number line is going to be super important, because we need to state the inequality as either an and, a between inequality, or an or, an outside inequality. Okay? But the number line is really what drives getting that final answer. So notice I have the same polynomial here, but I'm using different inequality signs with that same polynomial. The reason is just to show you the vast difference that the inequality sign is going to make on your solution set. And yeah, I have more explanation on it already typed out underneath, but it's so much better if you see me do this and see my answer. Okay, so we'll start with x squared minus x minus 12 is less than 0. We'll start here. First things first, is one side 0 and the other side all polynomial? Yes. So that's the first thing you need, because the zero product law is still at play. What I do is I pretend that this is just an equal sign. So I pretend I don't have an inequality sign for a sec, and I just factor and t-chart. So what are the factors of 12 that subtract to give me a negative 1? Well, that would be x minus 4 and x plus 3. Okay, then I t-chart, set each factor equal to 0, x equals 4, and x plus 3 equals 0, so x equals negative 3. Okay, what that just gave me are not my final answers, unlike the last lesson. What that gave me are my numbers in question. So the numbers that I am going to start with on my number line. So I know I need from at least negative 3 to 4 represented on my number line below. Okay, so notice I'm putting enough hash marks down here where I'm going to be able to fit from negative 3 to positive 4 in a scale, right? So negative 3, negative 2, negative 1, 0, and I'm going to put 0 on here and kind of highlight it. We'll get back to y. Then 1, 2, 3, 4. There we go. Now is when I think back to what was my inequality sign. Okay, so it was a less than. So that means that I don't color in my dots, right? These are open circles over my two numbers in question, my negative 3 and my positive 4. Now, because I don't know if I'm in between or outside for my answers, it's one or the other. But because I don't know it, I need a test value. And the test value I always choose, because it's so easy to multiply by, is 0. Because we know anything times 0 is 0. So I choose 0 as my test number. And what I do is I plug 0 back into the original inequality. Because now that I know what those values, what those basic values, the 4 and the negative 3 are, where I've got my circles, now I need to know, well, do I cover this which includes 0, or do I cover this, which does not include 0? So if 0 makes this original inequality statement true, I get to cover it with a line. And if it doesn't, I don't cover it with a line and I'm outside. But I always pick 0 because it's just so easy to multiply by. So let's see, 0 squared is 0, and negative 0, well, 0 minus 0 is still 0. And then 0 minus 12, well, that's negative 12. So negative 12 is less than or equal to, is less than 0. Is that a true statement? Is negative 12 less than 0? So since negative 12 is less than 0, and that's true, that means I need to cover this 0 here with a line. So that's going to mean a betweenie inequality. So notice that. Now I write the between inequality. Negative 3 is less than x, which is less than 4. That's my final answer. And notice, you must state the inequality, right? Just above where I am. You must state the inequality answer. There it is. So we've got the number line to back it up, the solution set. We've got the checkpoint to back it up. There's our final inequality answer. So we kind of pretend, and I'll do it again, we pretend like we've just got an equal sign, but in the end, we need to know that it's definitely an inequality sign, okay? So again, let's pretend it's an equal sign. To factor, this is to factor. So the factors of 12 that subtract to give me 1 are minus 4, negative 1, minus 4 and positive 3 in T-chart. So x minus 4 equals 0. So we know x equals 4 is one of our numbers in question. And x plus 3 equals 0. So we know that x equals negative 3. That's our other kind of number in question, right? So we go down to our number line and we put enough hash marks to include both of those. And notice with my hash marks, I'm fairly evenly spaced, leaving plenty of room. Negative 2, negative 1, 0. There's going to be my checkpoint. 1, 2, 3, 4. Got it. Open circles. Ooh, that's my alarm. Open circles over both of those, right? Now, I'm going to pick 0 because it's so easy to plug in and check. And I'm going to plug it back into the original inequality. Let me zoom out so you can see. Oh, we had a little freeze go here. Hold on. It'll catch up. It does this once in a while. Look, I'm moving my paper, right? Okay, well. I'm going to stop here, figure out why that froze real quick, and I will get back to you. There we are. Okay. Okay, so going to plug back in my 0. I do actually need to pause it, though, because I got to go. But 0 squared is 0. Minus 0 is still 0. 0 minus 12 is negative 12 is greater than 0. Now, is this statement true? Is negative 12 greater than 0? No. So since negative 12 is not greater than 0, you do not cover 0 here, which in our case, because of where the open circles are, means we're heading outside. So now I state my final inequality that x has to be less than negative 3 over here, or, because they're not connected, so they're two separate things, x has to be greater than 4 over here. And you state that final inequality just like I just did. Okay? Perfect place to pause, and we shall come back momentarily. All right? Here we go. Oh, that's what I wanted. And I'll be right back. Back from my meeting, guys. Sorry about that. Had a quick meeting interrupted our video. So at least you had a chance to kind of take this in. The nice thing about these is you can kind of tell based on once you get your whole polynomial on the other side of your inequality sign and your 0, on again, right? This is just lovely. There it is. All right, sorry about that again, guys. Yeah, it's just like teaching in a regular classroom, nothing but interruptions, right? So, okay, we were talking about how you get all your polynomial on one side of your inequality sign, you got your zero on the other. This is pretty nice because I hope you can see it right now. This is why I did it this way. The same polynomial less than gets you that betweeny, and that same polynomial, those same numbers in question, but a greater than got you outside. So by rule, we can typically say that the less thans are going to give us the betweeny inequalities, and the greater thans are going to give us the or inequalities, the outsides. Okay. But just to be safe, I always do a checkpoint just to make sure, because I love this rule, but I have to do this because I just need to be sure. Okay. I just can't memorize every rule. And so if I do this check each time, then I know I'm always right with that final inequality that I'm saying. Okay. So again, I know that the work is already here on top of my work. And I know that that kind of rule is there for you, but I would still do this checkpoint, and I would pick 0 or 1. I'd pick an easy integer to plug in as my checkpoint. Okay. So speaking of, let's just do a couple more sample problems. And here we go. Just do a couple more sample problems. I was just hoping that it didn't freeze on me again. Okay, are we already 0 on one side and the rest of my polynomial on the other? Yes, so we can get going on our factoring. So what are the factors of 24 that will subtract to give me a -5? So 8 and 3. So x minus 8, because bigger factor, same sign as middle. And since end is negative, the other factor gets the other sign. Now we t-chart, we're pretending an equal sign, right? X minus 8 equals 0, x plus 3 equals 0. We get x equals -3 and x equals 8. And so those are our numbers in question to put on our number line. So we know that on our number line, we're going to have to represent from -3 all the way to +8. So plenty of hash marks. Again, try to make things fairly equally spaced. And let's get -3 over here. -2, -1, 0 is going to be my checkpoint. 1, 2, 3, 4, 5, 6, 7, 8. There we go. So let's see. This was a greater than or equal to. Okay, so that's close dot over the -3 and the 8 as our numbers in question. Let's do 0 as our checkpoint. So let's plug that into the original inequality. So 0 squared minus 5 times 0 minus 24. We want to be greater than or equal to 0. And because these both zero out, this is why I pick 0 as my plug-in, right? Those zero out. And we end up with -24 is greater than or equal to 0. Is that a true statement? Is -24 greater than or equal to 0? No. So because -24 is not greater than or equal to 0, you cannot cover your checkpoint with your line. Since your checkpoint is between the two dots, that means that you're going to be outside, okay? That means that you're going to be outside, and this is an or. So now what we do for our final answer is we state our final inequality. Over here, x is less than or equal to -3, or over here, x is greater than or equal to 8. And I'm just going to put it in French curly braces to highlight that's my final answer, right? I know that that's my final answer, and I have to state that. Now, just quickly, greater than was going to be an or. See that? Okay. Next one. Well, we've got our whole polynomial on one side of the inequality and the 0 on the other side of the inequality. So Let's factor this guy. And it is a 5-line method one if you're a 5-line subscriber. If you're just a guess and check, that's cool too. But I'll do the 5 lines for you just to kind of review. We got our 2 under the front factor, our 2 under the back factor, and then this one over here is where I'm going to put the middle term and its sign. So the middle number and its sign is -1. And I am cross multiplying these guys in order to get 2 numbers that subtract, because the end term is negative, to give me -1. Okay, so let's see. The only factors of 2 are 2 and 1, so they've got to be here. And the only factors of 3 are 3 and 1. So these are both prime, so it makes it a little bit quicker. I know that they need to subtract to give me -1, right? So if I do it this order, 1 times 3 is 3, 2 times 1 is 2, and in order for those to subtract to get a -1, it's a -3 and a +2. Scooch the sign right back over and fill your binomial straight across, right? So 2x minus 3, 1x plus 1, or just x plus 1, just like that. And now those are the binomials I t-chart. So I have my work here for showing my 5-line, but this is where I t-chart. The 2 binomials I t-chart, 2x minus 3 equals 0, and x plus 1 equals 0, just like this. Now over here, I'm not going to get an integer answer because I have a number in front of my x, and that's fine. We're fine with that. I'm just going to show you my linear moves in order to get my x all by itself. So I add 3 to both sides. Now I need to divide both sides by 2, and I get x equals 3/2. Or if you do plug that into your graphing calculator to get a decimal, you could say x equals 1.5. Okay. And again, that's a rational number, perfectly acceptable answer. We'll just plan for that when we scale our number line. So we'll plan for having halves when we scale our number line. Over here, subtract 1 from both sides. This one doesn't have a number in front of the x, so a lot easier to see. X equals -1. These are our numbers in question. So again, like I said, when I scale my number line this time, I'll plan for 1/2 to be part of my scale. So what I'll do is, let's put -1 here, then -1/2, then 0, then +1/2, then +1, then 1.5 right here, or 3/2. So this, and then this is my 2, right? So that's my halfway, that's my 1.5. So this one gets a closed dot right here, halfway between 1 and 2. And my other one that gets a closed dot is this -1, my 2 numbers in question. Now you'll note that I still have 0 as my checkpoint, because especially in a question like this, an easy multiplier is still 0. And so if I'm confused about other things, at least I've got 0 as my x. And so here, let's see what we get. We still get this to 0 out. We still get this to 0 out. So really you're left with -3 is less than or equal to 0. And is -3 smaller than 0? Yes, that is a true statement. So because that's a true statement, I cover it with my line connecting the 2 dots. Okay. If your 0 is not between your 2 dots, then you don't connect it that way. It would still be outside. Okay. You always just cover that last checkpoint. Now I need to state my final inequality, and I always state these as a between inequality. I'll do it down here. -1 is less than or equal to x, which is less than or equal to 3/2 or 1.5, whichever value representation you want to put there. I prefer that fraction, so I'm going to put the 3.5 or 3/2, right? 1.5 works just as well. Okay. Notice, again, less than, final answer, between inequality. So it's kind of a little rule that you can remember if you want to remember more rules. If you don't want to remember more rules, well, you have to do the checkpoint anyway. So there you go. Okay. So you need to make sure you know how to factor. You pretend you got an equal sign in your T-chart. You get your numbers in question, place those on the number line, and then your checkpoint is something easy like a 0. That's what I used every time. It's just so easy to multiply by, right? State your final inequality based on where your checkpoint falls with your values in question. Okay? That's what we really need to have. That final inequality answer is key. Okay? That's what I'll be looking for on this particular homework. So please be mindful of that. That'll be the first thing I'll notice. Okay? So be prepared. Watch again if you need to figure out how I'm doing this. Okay? Or even better, ask me for help. More than happy to help you with this. So please make sure you take advantage either during your class or during that after school time if you're a virtual kid. Okay? All right, guys, I shall be seeing you. That is the end of chapter 3. I am going to do a chapter 3 review video just because there were so many equations and inequalities we solved, and I want you to be able to do any of them. Okay? All right, one more video, but chapter 3 lessons are done, and I shall be seeing you guys for that last review. Good luck. Let me know if you need anything. Bye, guys.